Hello, my dear students. Now let's discuss the second part. So here I'll remind you few more equations that we already learned. That is rebounding of a ball on collision with floor. Okay, rebounding of a ball on collision with floor, that is, we are dropping a ball from a particular height. Okay, when we are dropping, the initial velocity will be 0. We are dropping it from a height h0 to the ground. Okay, so it will hit the ground and rise to a particular height. Let's put the height after nth rebound as hn. Okay, so what is the equation for velocity? Velocity after nth rebound. After nth rebound. Velocity after nth rebound. Yes, you remember the equation Vn is equal to e raised to n into V0. Alright, where V0 is the final velocity when the ball hit the ground for the first time. Alright, so here that final velocity V0 will be equal to, yes, root of 2gh0. You may be remembering this. Alright, and what will be the initial time taken? Yes, the initial time taken t0 will be equal to root of 2h0 by g. Alright, these are equation you already learned in motion in a straight line. Okay, now what will be the height after nth rebound? Height after nth rebound. Height after nth rebound. Yes, your equation will be hn is equal to e raised to 2n into h0. Okay, now third equation is total vertical distance covered before it stops bouncing. Yes, our equation was h is equal to h0 into 1 plus e square divided by 1 minus e square. Okay, now fourth one is total time taken to stop bouncing. So what is the total time taken to stop bouncing? The total time taken to stop bouncing will be 2h0 by g into 1 plus e by 1 minus e. Okay, now next equation is time after nth rebound. Time after nth rebound. The equation is Tn is equal to e raised to n times T0. What is T0? Yes, the T0 is already given here. Root of 2h0 by g. Alright. Now, the sixth equation is the equation for average speed, okay, the average speed, V average will be equal to, we know it is total distance by total time. So what will come? Yes, it will be root of GH by 2 into 1 plus E square by 1 plus E the whole square, right? And the seventh equation, average velocity. What is average velocity? Total displacement by total time, right? So that will be equal to root of GH by 2 into 1 minus E by 1 plus E. Okay, 1 minus E by 1 plus E. So these are the most important equations under the topic rebounding of a ball on collision with floor. Okay, so now let's move on to the questions. The first question, we have done many questions in the classroom. Okay, so the first question, here it is, two balls of equal masses undergo a head-on collision with speed 6 meters per second moving in opposite direction. If the coefficient of restitution is 1 by 3, find the speed of each ball after impact in meter per second. Now, the question is like, there are two equal masses which are moving in opposite directions. So here U1 is 6 meter per second, and this mass, an identical mass which is coming in the opposite direction with same speed, 6 meter per second, that is our U2. Now they are getting collided, and the coefficient of restitution is mentioned here as 1 by 3. Okay, the coefficient of restitution is given as 1 by 3. The question is, find the speed of each ball after the impact. After impact, what will be the speed? That is what we need to find. Okay, so let's apply the condition of momentum conservation. We can write that, suppose it have a final velocity say v1, it have a final velocity say v2. Then applying momentum conservation, m or 6m, okay, that is the initial velocity of the first body, 6m minus 6m. Why we took minus? Because if you take this direction as positive, then this body is moving in opposite, therefore the momentum will be taken negative. Alright, so 6m minus 6m is equal to m v1 plus m v2. Okay, so your answer will be v1 plus v2 is equal to 0, equation 1. Okay, now we also know that the coefficient of restitution is E is equal to v2 minus v1 by u1 minus u2. Alright, so applying in it, 1 by 3 is equal to v2 minus v1 by u1 minus u2. What is u1 minus u2? Yes, the u1 is 6 to the right side. Okay, so it is 6 minus, what about v1? V1, what is u1? u2. Alright, u1 is 6. What about u2? The u2 is in the negative direction, so you will take minus 6. Alright, so it is minus 6. So that will be like 6 plus 6, 12. That 12 here is taken to this side, so 12 by 3. 12 by 3 will be 4. Alright, so 4 is equal to v2 minus v1, equation number 2. Let's solve the 1 and 2. You can add them. Okay, you add both the equation 1 plus 2. What you will come across? Yes, v1 cancel agu. It will be 2 v2 will be equal to 4, and your v2 will be equal to 2 meter per second. And what about V1? Yes, you can substitute the V2 in the first equation to obtain V1. So that V1 plus 2 is equal to 0. So V1 is equal to minus 2 meter per second. So what you can understand here it is that the two bodies after collision have same speed, that is 2 meter per second, but they are moving in opposite direction. Okay. So that is the answer. Hope you understood it. Now let's move on to the next question. The question is, a particle of mass 2 kg moving with velocity 5 I cap meter per second collide head on with another particle of mass 3 kg moving with velocity minus 2 I cap meter per second. So first of all, let's draw that situation. There is a mass 2 kg and it is moving with velocity 5 I cap, which means it is x direction, 5 meter per second, which is the initial velocity u1, and it have a head-on collision with another particle whose mass is 3 kg. Okay, and it is moving with the velocity say minus 2 I cap. What do you mean by minus I? It means negative x direction. Alright, so in negative x direction the initial velocity is 2 meter per second. Okay, now after the collision the first particle has speed. So collision finish ആയിடுச்சு അപ്പുറം first velocity of the first mass will be equal to final velocity will be minus 1.6 meter per second, right? 1.6 meter per second. Yes, in negative x direction so we can put minus. All right, minus 1.6 meter per second. Now you are asked to find the velocity of center of mass after the collision. Okay, the next question is velocity of the second particle after the collision. So first of all, let's find the answer for the B part. Okay, even if we find the answer for the A part, it is not a problem. That is, the velocity of center of mass remains the same before and after collision since the momentum is conserved. Okay, but anyway, in order to avoid any confusion for you guys, let's do it like velocity of second particle we will first find. Okay, so that can be found using the momentum conservation. So what is the initial momentum? 2 into 5, okay, m1 u1 plus m2 u2, like that you will do, right? So 2 into 5, that is the initial momentum of the first body. For this we have to take minus 2 as the velocity since it is the negative direction. So it will be minus 6, right? So 2 into 5 minus 3 into 2 is equal to, what is the final velocity, final momentum of the first body? Yes, 2 into minus 1.6, because the question clearly says that the first body is moving in the negative x direction, right? Negative x direction. Now plus m2 v2. What is m2 v2? 3 into v2. That is what we need to find, v2, right? So what will be the answer? 10 minus 6 is equal to minus 3.2 plus 3v2. So that will be 4 plus 3.2 is equal to 3v2. So that will be v2 is equal to 7.2 by 3. So that will be, in 7 it is 2 times, in 12 it is 4 times. So it is 2.4, right? So it is 2.4. If you want to mention the direction, you can put I cap meter per second because it is positive, right? And it's a head-on collision. So no other possibility of y-axis or anything. Okay. So that's your answer. Now let's answer for the A question. What is A question? the velocity of center of mass after the collision. Do you remember the equation for velocity of center of mass? The velocity of center of mass is m1 v1 plus m2 v2 by m1 plus m2, right? So let's substitute it. m1, what is m1? Yes, it is 2 times v1. What is v1 here? Yes, minus 1.6 plus m2 is 3 times v2 is 2.4 all divided by m1 plus m2, which is equal to 5, right? So what will be coming? Yes, upon solving this, 2 into minus 1.6, which is minus 3.2 plus 3 into 2.4. So that is 7.2 by 5. So you will get 4 by 5, which is equal to 0.8 meter per second. And this is also along I cap, right? Positive x-axis. Now, there is a C question. We have to find the coefficient of restitution, right? We are asked to find the coefficient of restitution. So, which is very simple. Do you remember the formula? Yes, V2 minus V1 by U1 minus U2. So, let's substitute. What is V2? That is 2.4 minus V1, which is minus 1.6 all divided by U1. What is U1 here? U1 is 5 minus U2. U2, it is in the negative direction, therefore you have to take minus 2. Don't forget. So 5 minus 2. So what will come? Yes, your answer will be like 4 by 7. Alright. So that is the coefficient of restitution. I hope you guys understood this. Alright. Okay. Now, let's go with question number 3. What is question number 3? The question number 3 is, a body of mass 2 kg make an elastic collision with another body at rest and continue to move in the original direction with 1/4 of its original speed. Find mass of the second body. So there is a mass 2 kg. Okay. It makes an elastic collision with another body at rest. So there is another body whose mass is m2 and the initial velocity u2 is 0. So we don't know what is this velocity, so let u1 be equal to u. Okay, let's assume it is u. Now, after collision, what happens? After collision, this first mass continued to move. This first mass continued to move with 1/4 of its original velocity, which means the final velocity of the first body is u by 4. And we are asked to find the mass of the second body. So how we will approach this question? Let's do the momentum conservation. Assuming that the final velocity of m2 is v2. Okay, let's do the momentum conservation. We know the equation m1 u1 plus m2 u2 is equal to m1 v1 plus m2 v2. You should not forget. Okay, in most of the questions of collision, we will be applying momentum conservation only. Okay, so in momentum conservation, you can write it as 2 times u plus m2 u2, which is 0. Okay, anyway I am writing m2 into 0 is equal to 2 into u by 4 plus m2 v2. Fine. So this will be like 2u is equal to u by 2 plus m2 v2, right? So what will be your m2 v2? Your m2 v2 will be 2u minus u by 2. So that m2 v2 is equal to, it's 4u minus u, which is 3u by 2. Hope you understand this one. This is our first equation upon doing the momentum conservation. Now this is an elastic collision. They clearly tells that it is an elastic collision, right? Therefore, kinetic energy will be also conserved. Okay. So let's apply the kinetic energy conservation also. So kinetic energy conservation will be like half m1 u1 square plus half m2 u2 square is equal to half m1 v1 square plus half m2 v2 square. So let's apply in it. What will come? It will be like half into m1. m1 is 2 into u1. The u1 is u square plus half into m2 into u2 square. Anyway, that will be 0. Okay, anyway, will be equal to half into m1 is 2 into v1 is u square by 16 will come, right? Upon squaring it will become u square by 16 plus half into m2 into v2 square. Now let's try to solve this one. You can cut this half, so remaining is just u square. So it is u square is equal to, here also this can be cancelled. So it will be remaining is u square by 16 plus, okay, half m2 v2 square, alright. So here, if you take this to the left side, it becomes u square minus u square by 16 is equal to half into m2 into, we are asked to find the mass, alright. So we don't require this v2 here. So from here let's make an equation for v2. So v2 will be equal to 3u by 2 times m2. So let's call this as equation 1. Okay, and let's substitute this equation 1 over here. Okay, let's substitute this equation over here. So what will come? Instead of v2 square you can write 9 u square by 4 m2 square. Okay, so m2 is cancelled. Now what will be the answer? It will be like 15 u square by 16 is equal to 9 by 8 times u square by m2, right? So again let's cancel the u square term. So what will be m2? The m2 will be equal to 9 times 16 divided by 15 times 8. So 8 and 16 cancels, you get 2, right? You can cancel this with 3. So here 3, here it will become 5. So 6 by 5, which is equal to 1.2 kilogram, right? 6 by 5, which is equal to 1.2 kilogram. So the m2 is 1.2 kilogram. Now let's move on to the fourth question. A body of mass 1 kg moving with velocity 1 meter per second makes an elastic one-dimensional collision with an identical stationary body. They are in contact for a brief period, 1 second. Their force of interaction increases from 0 to f0 linearly in 0.5 seconds and decrease linearly to 0 in a further 0.5 seconds as shown in figure. Find the magnitude of force F0 in Newton. So there is a mass 1 kg. It's moving with an initial velocity u1 1 meter per second. Okay. It makes an elastic one-dimensional collision with an identical stationary mass. So there is a stationary mass which is also 1 kg and whose initial velocity is 0. So this mass is going to collide with this mass, okay, and they are in contact for 1 second. So definitely this mass is going to apply some force over the other mass, alright? And what will happen? We know that after collision, since they are identical masses, the first one, suppose this is the first, this is the second, then the first one, okay, this is the first one, that will come to rest, and the second one, which is 1 kg, it will start to move with 1 meter per second, alright? We are asked to find the force here. We know that impulse is equal to change in momentum. And how to calculate the impulse in this situation? We know impulse is the area under FT graph, alright? The FT graph area find panniyal, in the graph in the area find panniyal, you get the impulse, alright? Area of FT graph. So how to calculate that area? Yes, it's a triangle, therefore it will be half into base into height. Change in momentum. Okay, let's consider the second body and we calculate the change in momentum as final momentum minus initial momentum. What is the final momentum? 1 into 1. What is the initial momentum? 1 into 0. Okay. Now it will be like half into base. The base value here is 1 and the height here is f0. F0 is we need to find. So here it is half into 1 into f0 is equal to 1. So that your f0 will be equal to 2 Newton. Alright? Okay, fine. So I hope you understood this question. It's a good question, right? Now, let's move on to the fifth question. A particle of mass m moving with velocity v makes head-on collision with another particle of same mass initially at rest. Find the velocity of first particle after the collision. So there is a particle whose mass is m. It is moving with velocity v. Now read the question. It makes head-on elastic collision. Head-on elastic collision. Another mass which is initially at rest. Alright, this is initially at rest. Now what is the question? Find the velocity of the first particle after collision. Now does it comes under any cases that we have learned? Yes. This and this masses are identical. So the velocity will interchange. So this mass go and collide with it, which is initially at rest. So what happens? The first body will come to rest and the second body will start to move with the v velocity. Right? So what will be your answer? Yes, after collision, first particle come to rest. First particle come to rest. Okay. So that's it. Now let's go ahead with the sixth question. A body moving towards a body of finite mass at rest collide with it. It is impossible that, read the question carefully. It is impossible that, what is the impossible situation here? It is impossible that both bodies come to rest, right? Because the momentum have to be conserved. If both bodies come to rest, then the final momentum of the system will become zero, but the initial momentum is not zero here. Therefore, momentum conservation will become wrong. So the both bodies should not come to rest. Okay. So it is impossible that both bodies are coming to rest. Now, whether there is any other option, let's see. Both bodies move after collision, which is a possible case, right? Now the moving body stops and the body at rest start moving. That is also possible, as we have discussed a case in elastic collision where the masses are identical and there was a subcase too, right? Now what about fourth one? The stationary body remains stationary and moving body rebounds. Now what about the possibility of this statement? That is, stationary body remains stationary, moving body rebound. This is a case, special case we discussed. This is a special case we discussed when the mass is heavy. That is, we can consider like it is infinite, right? But here the question says that it is a finite mass at rest. Therefore, this special case is also not applicable. Therefore, the fourth is also impossible. So there is two impossible cases, that is 1 as well as 4. There are two impossible cases. Okay. Now, let's see the question number 7. A body of mass 2 kg having velocity 3 meter per second collide with a body of 1 kg mass moving with a velocity 4 meter per second in the opposite direction. After collision, both bodies stick together and move with a common velocity. Find the velocity. So this is something related to perfectly inelastic collision, right? Perfectly inelastic collision. So you take this as a homework, try it out, and let me see how many of you are finding the answer. So we'll have few more questions doing in the third part. Okay.